Hello everyone. Today I will present the paper Self-Training with Noisy Student Improves ImageNet Classification. Recently, deep learning-based image classification has achieved remarkable success. However, SOTA models are usually trained using supervised learning, which requires a large number of labeled images or weakly labeled images like those on Instagram. The authors of this paper, however, considered using unlabeled images to train their model. The main concept of this paper is very simple. Firstly, they trained a teacher model with labeled images. Secondly, they inferred pseudo-labels for the unlabeled images using the teacher model. Thirdly, they trained a student model with both labeled and pseudo-labeled images. Lastly, they used the student model as a new teacher for a new, larger student model and iterated the procedure from the second step. During training, they used equal or larger student models that can run better from a larger data set. This allowed the student model to run more complex patterns and improve accuracy. Additionally, they added noise to the student model to prevent overfitting on the pseudo-labeled, unlabeled images. The authors used labeled images from ImageNet 2012 and 300 million unlabeled images from the JFT dataset. Although the JFT dataset has labels, the authors ignored these labels. Their baseline models were EfficientNet. EfficientNet B0 became the first teacher model to predict labels for the JFT dataset. They then scaled up to EfficientNet B7. Finally, they chose B7 as the teacher model to obtain L2, which is wider and deeper. They tested many combinations of models from B0 to B7 to obtain L2. And all combinations performed better than the normal EfficientNet. The model in this paper outperformed previous SOTA models. And to check the robustness of the model, the authors evaluated it on several other datasets. ImageNet A was used for top-1 accuracy. ImageNet C was used for mean corruption error. ImageNet P was used for mean flip rate. As you can see, only the author's model can predict the correct classes shown in black text. The red text indicates incorrect predictions made by the normal EfficientNet. The authors evaluated the impact of each noise factor and proved that the combination of all noises achieved the best performance. In this paper, the authors demonstrated that the noisy student model can enhance both accuracy and robustness. Thank you for your attention.